Okay, we're going to do our first part of Unit 3 review. So, this is where we were introduced to parallel lines. So, the little red triangles here represent the parallel lines, and a transversal that cuts across. And we learned all different types of angle measures. So, there's 8 little angle measures here. Let me go ahead and number a few of these and just make sure that we're on track. So, for example, I could call this 1, 2, 3, 4, 5, 6, 7, and 8. And we learned some valuable things about these. For example, we learned that 1, 4, 5, and 8 would all be equal by different relationships. So these right here, these two right here are vertical angles. These are alternate interiors between 4 and 5. You could also call these corresponding angles. Remember, one in, one out. Corresponding angles this way as well. 1 and 8 are alternate interiors. So you have all those. I'm going to use a different color here to mark the other ones. So we have 2, 3, 6, and 7 are also equal. 2 and 6, again by corresponding angles. 2 and 7 by alternate exterior angles. 3 and 6 by alternate interior angles. So, along with that, we learned about postulates and such that we'll be talking about. The first step that we're going to look at as we review here is how to find x. So, our goal is just, and I've got it scrolled down, so I'm going to write this find x. This is what we're doing. So, you have to know the relationship between these two. 85 and 21x plus 1, these two little angle measures right here, are alternate interior. If you're alternate interior angles, you are equal. There was a chart in your packet, your unit packet, that you might want to go back and look at those and remember which ones are equal, which ones add to be 180. These that I have displayed right here are all equal angles. Okay, so these two right here are going to be equal. So we're going to set up a little equation, 21x plus 1 equals 85. Okay, and we're going to go ahead and solve this little equation. If you like to draw the line down the middle, you can draw the line. I'm not really here to teach you to solve differently, just to help you review this. So the first thing I need to do on this one is I need to subtract 1 from both sides. Okay, that gives me 21x. This zeroes out, and 85 minus 1 is 84. Okay, our next step is to get rid of the 21, so we're going to divide by 21, and that gives me x equaling 4. Okay, so that's just finding x. If I needed the actual angle measure, and you could check this, you could take the x and substitute it in and do 21 times 4 plus 1. 21 times 4 is 84, and 84 plus 1 is 85, which gives us a check because we said these two were equal angle measures. Okay, let's look at this one right here. I probably won't do all these, but I'll do a couple. This one right here, again, by alternate interior, they're equal. So that means we're going to set these two equations up to equal each other. So I have 15x plus 5, and it's going to equal this angle measure, negative 5 plus 17x. And as we go about here to solve, we need to get our x's on the same side. Most of you like to move the smaller x. So I'm going to subtract 15x from both sides. This zeroes out, drop down your 5, drop down our negative 5, and 17x minus 15x is a positive 2x. Then we're going to go ahead and take, and we're going to add our negative 5 to both sides. So we're going to add 5 to get rid of it. 5 plus 5 is 10. This zeroes out, and we get 2x. Okay, and some of you have already figured out when you divide by 2, x is going to equal 5. Okay, and we can do a check. Like I said, we can plug this in for x. So if we substitute in for x, we get negative 5 plus 17 times 5. Okay, and we could do this math, and it should equal the exact same thing as the other side when we plug it in. So all these problems have a check to them. So you can kind of check numbers and see how it works and see what it equals. So we have negative 5. I'm going to work from the top here. Negative 5 plus 80. Negative 5 plus 80. I'm sorry, that's not 80. Let's try that again. How about 85? I think I was already solving it in my head. Okay, so negative 5 plus 85 would be 80. So that would check. And then we can go over here. This angle, when I do all this math, should equal 80. So we're going to check that. So we have 15 times 5 plus 5. So 75 plus 5 equals what? 80. So this would be a check. Okay. Again, these right here are corresponding angles. You have one in, one out. So you could set up your equation like this if you want to practice. They're set equal to each other. Okay, so set equal to each other. These are equal by vertical angles, so they're going to be the same angle measure. If you want to practice this one, you can pause the video, set them equal to each other, and you can see what you can get with that. Okay, so this is just the basic where we started finding angle measures, okay? So our basic one. Now we're going to scroll down just a little bit. Let me clear the page because when I scroll down, all of this will pop up on it. I'm sure there's a faster way than this to erase, but new software working with it here, you'll have to bear with me as I practice my erasing skills. All right, so here we go. Let's scroll down. I've given you a couple of different right now type. These are still equal to each other because they're vertical angles. But if you look at these two, we called these linear pair because they're right along this straight line. So together they have to add to be 180. Okay, so that means 128 plus x plus 58. So this was the first angle measure. This is the second angle measure. And together they have to add to be 180. Okay, we talked about just combining like terms. Well, we see them down here. So we also talked about just doing x plus x, which is 2x, be the same right here. You would get a 2x. And then you would add your 58 and 128. Which is 186. So plus 186 equals 180. Okay, I'm going to erase just a second here to give myself a little bit of room to work. So real easy equation to solve. So we're going to subtract 186 from both sides. You're going to get, I'm going to come down here, 2x equaling 180 minus 186 is going to equal a negative 6, and then you're going to divide by 2, and x will equal a negative 3. Now, I don't want you to confuse this with you have an angle measure that equals negative 3 because we haven't plugged this in. If I did 128 plus a negative 3, I would get 125 here. Let me write that in a different color. I would get 125. So let me say what I just did. I took negative 3 and I substituted in for x. 128 plus a negative 3 would be 125. Okay? And then if I put negative 3 in here plus 58, that would equal 55. And together, 125 plus 55 equals 180 degrees. Okay, so again, it's checkable. These two right here are consecutive interior angles, so they also add to equal 180. Okay, add to equal 180 degrees. These two are set equal to each other because they're vertical angles again. So just a quick review on our angles, a little bit here and what they do. So let's scroll down just a moment. Okay. And we're going to talk about how to identify these and which makes these true to be parallel lines. So this is where we led to after we kind of started adding and finding angle measures. So let's talk for just a second how these work out. You have three parallel lines. I'm going to name these parallel lines. So let's call them M, N, O. Okay. And then I have this transversal T that cuts through here. And they give me these two angle measures right here, and I'm supposed to decide if they are parallel lines. Well, we know they look parallel, right? But let's use an angle postulate to prove that they're parallel. So if we look at these two angles, their relationship would be I have um, one angle right here and this angle right here, and that would make them corresponding angle measures. They're on the same side, so they're corresponding angles. That would make them equal, which would prove that lines N is parallel to line O. Okay, just we're not doing proofs, we're just kind of proving through a sentence that they are. If we look over here at this one, as we go across, they have a lot going on because I have this one cutting out. When we look at these two angle measures, again, you're going to have corresponding angles because this one's on the outside, this one's on the inside. And I would have to name my angle measures again. So we'll stay with M and N. And this is my transversal T. So if I look at this by corresponding angles, okay, that proves that line M is parallel to line N. So just a little bit with that. Let me scroll down through here and see if I see another interesting one that I would like to share with you um, as we go through. You guys did really good on this, so I'm not too worried. Click the wrong thing. Here we go. And this one right here, let's look at this one. MNO again and transversal T, so just putting some names on my lines. I see these two right here, and I have to come with a relationship. When you see this, you kind of have to ignore this middle line, like if you can just kind of make it go away, and just concentrate on the lines M and O. X and Y would then both be on the inside, and they jump across the transversal T, so that makes them alternate. So inside is interior, and they alternate over there, so they're alternate interior angles. And we would use this to prove that not M and N, but M and O, because that's the two lines that these are on. So line M is parallel to line O. Okay. And this one is back to alternate interior angles. So as we look, Y and X, they're on the inside of these two parallel lines, and they alternate across. So this would be alternate interior angles, and it proves that M is parallel to N. Okay, so very basic, very simple with that as we prove that those are. Let's scroll down and see what else I put on here, if anything, for us. That is it. So as we're looking through those, just to help you out a little bit, and remember those, you can go back in your packet, Unit 3 again, and review all those before you hit your 9 weeks test coming up here. Good luck.